everybody. So we are going to begin here with our last CFA, CFA number 6, talking about statistics. And so this is everything we've been doing for the last couple of days. So remember, our CFA is going to be a really good, our CFA review will be a really good review for the actual CFA, and all of these are very similar to test questions we might actually see when we take our final exam next week. So let's get right into it. Our first question says, the data below shows the donations in dollars a charity received from 8 donors at a fundraising event. And it says, which plot correctly represents this data? So looking at this, as soon as we see our data, first thing I want us to do, first reaction, is going to be to put it in Desmos. And so I kind of went ahead and put all of these in Desmos for us. So it just makes this a little bit easier for me. I have our Desmos. And when we're looking at a box plot, we know that we need the minimum, the Q1, the median, the Q3, and the max. So if I need that in Desmos, I can do our 5-number summary under our statistics function. Where is it? Right there. Okay, I named our column X. So I'm just going to put X in there. Do I need to put X1? X1. There we go. Okay, so we have our numbers. So our minimum was 470. Our Q1 was 565. Our median was 665. Our Q3 was 750. And our max was 830. So let's go ahead and look at our graphs right here. So we know the min is 480 or 470. And it looks like all of them have a minimum of 470. So we can't use minimum to tell these apart. Let's look at maximum, the end. So that's 830. They look like they all end at about 830. So now we can start looking at, let's just say, the median, because that's in the middle, 665. So that would be roughly, I don't know, right here. Well, this would be the median. That does not match up, so we can mark out A. Again, the median is 665. That'll be right there. Here's the median. That does not match up, so we got to knock B out. That's a little bit closer, but it's not close enough. Let's look at D. Down here is the median at 665, and so that looks like it matches up. Our Q1 was also 565, so a little bit, above 550, so kind of right there. It looks like that matches up. And then our Q3 was 750, and that perfectly matches up right there. So D is going to be our final answer here. So let's go ahead and look at number 2. I'm going to pull up our data that we need. So remember, you guys are going to make a table on these and put in our data. So it says the data set below shows the total number of hours that Jalen and Marcus work each day from 1 week. And so we see our data. Let's go through and read our answers. It says, which statement best describes the data set? Then Jalen's standard deviation was about 0.8 higher than Marcus's. Marcus's standard deviation was about 0.8 higher than Jalen's. Marcus and Jalen had the same interquartile range. Jalen had a greater interquartile range than Marcus. So let's talk for a second. So we know we're looking at for standard deviation or the interquartile range. So we know we have 2 different types of standard deviations. The numbers will differ a little bit. But this problem is talking about the total number of hours that they worked from this 1 week. And we are just worried about this 1 week. We're not worried about the whole year, but we are worried about just total numbers. So this is going to be all the numbers or all the hours. That would be a population standard deviation. So if we go over to our Desmos, I go to my functions. We're going to use STDEVP because we're looking at the whole population right here. Okay, so I'm going to make us a little table so we can have our data organized. So we know we're looking at Jalen, we're looking at Marcus. We know we need their standard deviation and we know we need their inner quartile range. So let's find the standard deviation of Jalen, and I just put J up there. Because remember, you can make the names of the columns whatever you want. We just have to pay attention to what they are. And we see his standard deviation, if we round it, would be 1.96. Okay, if we plug in, if we go then and look at Marcus. So let's do the exact same thing. Standard deviation of the population, plug in M for Marcus. We get 2.79. Okay, then I want to find the IQR of Jalen. So for the IQR of Jalen, we need the stats. So I'm going to put in our stats. And remember, you guys can just press the function button if you want. You can type it in if you want. It really doesn't matter as long as you type it in correctly. So let's look up Jalen. Okay, so for our IQR, we need two things. We need Q3 and Q1. So we would have 7 minus 3.5. If I subtract those, 7 minus 3.5, that gives me 3.5. Now let's look up for Marcus. So I'm putting the M. See how my data is changing. Again, we need the IQR, so Q3 minus Q1. So that is 10 minus 4.5, and that'll give us 5.5. So we can close out Desmos now. So let's see which of our answers are correct. It says Jalen's standard deviation was about 0.8 higher than Marcus, okay? Let's figure out what the difference is right here. So if it says Jaden's standard deviation was about 0.8 higher, and Marcus's was 2.78, so let's go ahead and subtract them. I guess I shouldn't have closed my Desmos yet. So 2.79 minus 1.96. Okay, and we do that, we get 0.83. We don't need to subtract the IQRs because we already did that. So Jaden's standard deviation was about 0.8 higher than Marcus. Whose was higher? If we look, Marcus's was higher. So that's not true that it says Jaden's was higher. So we can mark out A. If we keep going, it says Marcus's standard deviation was about 0.8 higher than Jalen's. Well, if we see right here, we got 0.83 as their difference. Marcus's is definitely higher, so I'm going to put a little check mark by B. B might be the correct answer. Keep going. Marcus and Jalen had the same interquartile range. Well, if we look, one's 3.5, one's 5.5. Those aren't the same. And it said Jalen had the greater interquartile range than Marcus. Well, if we look, Marcus has the bigger interquartile range of 5.5. So we can mark that out. That means our correct answer has to be B. Let's keep going now. On number 3, let me pull up the data we need. So it says the price of a case of bottled water at 4 convenience stores and 4 grocery stores are recorded below. The convenience store, you can see the data. The grocery store, there's the data. And it says which statement is true. So it says there is more variability in prices at the grocery store than at the convenience store. There is more variability in prices at the convenience store than at the grocery store. So this word variability might be confusing us. But think of it as how much the numbers differ. So it's almost like the standard deviation right here. Keep reading. It says the median price at the grocery store is higher than at the convenience store. And then the mean price is higher at the convenience store. The mean price is lower at the convenience store than the grocery store. So again, just to keep all of our data organized here, I'm going to make us a little table and say, here is my convenience store information. Here is my grocery store. Okay, and we know we need the standard deviation. We also know from reading the answers, we need the median. And we also know that we need the mean. So I went ahead and put our numbers in Desmos. So to find standard deviation, and this is just talking about 4 grocery stores, not all the grocery stores. So that means we're going to use the normal standard deviation. I'm going to put in C because I put in C for convenience store. And we get 0.52. Okay, well, if I want to change that C to a G so we can look at the grocery stores, we get 0.29. That 8 would tell the other 8 to round up. Okay, now we want to look at the median. I'm going to show us 2 ways we can do it. We can either do our stats right here and then put in C. Or you can do it where you just click median and put in C. Either way, you get the median. It doesn't matter which way you do it. So we see that the median for the convenience stores is 4.175. And then if I put in the median for the grocery store, we get 3.54. Now we have to find the mean. And remember, that's a whole nother function in Desmos. We go back to our functions. We select mean. I'm going to look up convenience store or put in the C for convenience store. And we get 4.32. Most of y'all here are just going to use X1 and Y1, and that is totally fine. If you want to change it to C and G like I did, that's totally fine too. It's not going to make a difference. So I'm going to take my C out, put the G in, and so we get 3.54. So what we just need to do here is go through each answer and see which one is correct. So it says there is more variability in prices at the grocery store than the convenience store. So this is talking about a higher standard deviation. Well, we look right here. The convenience store has the higher standard deviation. So we know A cannot be correct. B says there is more variability in the prices at the convenience store than the grocery store. Well, the convenience store prices are kind of all over the place, and they have a higher standard deviation. So technically that's true. B might be our answer. Let's see if there's a better answer, though. C says the median price at the grocery store is higher than at the convenience store. Well, let's see who's higher. Looks like the grocery store is higher for the median. It looks like the grocery store is lower than the convenience store. So it says the median price at the grocery store is higher. That is not true. It's higher at the convenience store. And last one, it says the mean price at the convenience store is lower than the grocery store. Well, which one's lower here? We know convenience is higher, so we know that that is not true because the convenience store is higher for the mean by looking at our data. So that means B has to be our answer here. So we got 4 more. I'm going to do number 4 in this video, and then I'm going to stop it, and then the other 3 will be in the next video. So number 4 says the high and low temperatures in degrees Fahrenheit for a week are listed below. You see the highs, you see the lows. What is the difference in the interquartile ranges of highs and lows? So I'm going to go ahead and open up our Desmos. This is question 4. So I went ahead and put it in the table. I made the H column with all the highs and the L column with all the lows. Again, if you just want to use X1 and Y1, that is perfectly fine. There's nothing wrong with that. Just make sure you know the difference. So I'm going to make us a little information over here. Our highs and our lows. So for IQR, we need Q3 minus Q1. So that's going to come from our stats button. And so I'm looking at the highs first. So we have 61 minus 54. 54. So if we go down here, 61 minus 54, we get 7. Okay, now let's find the IQR for our lows. I'm going to put in an L. And so we see our Q3 is 39 minus our Q1 is 32. So 39 minus 32, again, we get 7. So let's go over here and look at our answers. This is what is the difference in the low temperatures? Or what is the difference in the IQRs? Well, last time I checked, 7 minus 7 is 0. So the only answer we have here that is 0 is going to be A. So that's the first part of this. There's only 7 questions on the CFA, so it's a little bit shorter. These next 3 will be in the next video. If you guys need any help, feel free to let me know. Thank you.